Hello Reshifters, in this video we're gonna discuss the newly contour node for the toon material and contour shaders. Right, we're gonna start with a simple cube and just apply a simple material, but I don't want to apply it directly to the cube. I want to apply it to a null, that's the parent of the cube. So when I throw another cube in, like so for instance, I don't have to reapply the material. Just handier. So we're gonna start with this setup. If you want, I can use RV, or let's use this thing first, basically the viewport IPR, right? And okay, let's start rendering. I can add a light, like a dome light, and everything looks nice and kind of flat. That's not a big issue. We're not here to discuss toon material in detail, but rather the contour shader, right? And the contour shader has its own port, especially for 3ds Max users. I strongly suggest you're using the material output instead of the regular way. This is the right way to use it in Redshift. Okay, and for the standard, I'm not gonna use the standard. I'm gonna simply use a constant color, which will be in this case white. And surprise, surprise, we're getting something. We're getting some sort of contour. But the question is this the expected contour that you want to have? And the answer is not quite. Now, there's a little issue with the viewport. It doesn't know what to do with constant color shaders or incandescent. It makes everything kind of flat in here and it's not great. So I'm gonna display this into hidden lines. Okay, it's a bit easy on the eyes. So you would expect when you start to render this, you expect to see these edges now, the ones that are outside and the ones that are inside, right? But if you're looking at the contour tries to do things, but it tries to do things based on normals and object detection. First, let's deal with the normals. Now, this little cube has the normals at basically 90 degrees apparently. But just apparently, because there's this little phone which is the normal smoothing angle in other DCCs, okay, which is set to 40 degrees. That's fine, no problem whatsoever. But I still can't see any contour inside. And by the way, you see the thickness of these lines? This thickness, the value that you see here, like 4, it's actually 4 pixels if the image is rendered at 1080p, so 1920 by 1080. Okay, for anything else, this scales up or down with the image, but this is what these 4 pixels mean. This is in pixel, right? So first, wait, there's 2 contours, internal and external. I don't see anything internal. Maybe it's the external one that's wrong here. Maybe I didn't use the internal properly. Let's disable the external. We disable the external, we see the internal, which is still the external somehow, which is a bit confusing at first, right? But remember that these edges are actually part of the object, so external or not, in this case it's external, or external around this because there's nothing around it, right? Nothing behind it, surrounding it, or in any way, it's just the environment, right? So what you can do though is use the normal type. The normal type can be smooth normals or geometric normals. Now let me explain you what the smooth normal is. Each vertex gets a normal from the face it's attached to. In this case, let's say this little point has 1, this face, and this face, so 3 faces. It gets 3 normals. These 3 normals can be averaged or smoothed into a different value, right? The geometric values are always perpendicular to the face normal. So you get 1, 2, and you get a third one that's pointing towards the camera. Okay, so when you smooth this out to make the shading smoother and not faceted, You can use that normal generated or the geometric normal. So that's the difference. If I switch from smooth to geometric, there you go. You see absolutely the same thing. Again, I'm gonna say, Adrian, you're bullshitting here. No, I'm not, because this goes into detection based on angle threshold. Okay, so let's switch that back to smooth, and well, we have 90 degrees between these faces, right? So let's try 89.999, and you can see them happening there. If I make it around bigger than 90, it won't show up, so I have to be just below. One little thing you're gonna notice is that, okay, great, we have internal edges visible, internal contour, great, fantastic, but they're thick. Why are they thick? Why are these 3 thicker than these 6? I only have one thickness, 4. Well, let me explain what thickness is actually. And for that, I'm gonna do one little thing and first switch the render to 1080p. Okay, and let's render, let's say, the top. Doesn't really matter which one, to be honest. And if you're looking at this value, the edge here, it should be around 4 pixels, but it's not. And it's actually just 2. And the question is, okay, well, it says 4, but it's 2. Why is that? Well, because the contour happens on different faces. Okay, let me explain that clearly. If you're rendering the perspective here, you're gonna notice that, hey, 1, 2, 3, 4, okay, this is about 4 pixels plus the anti-aliasing, it's, let's say, 4. Kind of the same thing happens here, 1, 2, 3, 4, okay, that's fine. That starts to make sense, but it kind of doesn't if you're looking at the edge. Why is this thinner? And it looks kind of like being half of that 4. Well, it does, and it makes sense when I start to explain how the contour is generated or detected. Let me add a little modifier here, or whatever you want to call it, it's called a deformer, right? That allows me to, because this cube is a generator, you can't select faces, but with this little modifier or deformer, you can. So here's the thing, this is a face or an object, consider it whatever you want, right? It detects some edges at some point, and these edges are 1, 2, 3, 4, or let's say 1, 2, 3, 4. But it also detects here, 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 and here, and here, 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 and here. So basically, all these edges are single or double contoured. And you're gonna ask me, what is double contoured? Actually, it's not kind of double contoured, but the contour we draw around this and around this, it's different. It's different. It's, let's say, each bit that the text contour has a contour, and this contour happens inside the face. That's the biggest thing. So you get a bit of contour in here, you get a bit of contour in here, you get a bit of contour in here and in here. But because this and this have the same thickness, it's whatever contour value here divided by 2, 4 divided by 2, it's 2. You have 2 pixels kind of here, 2 pixels kind of here, 2 here, 2 here. But wait, here you only have 2 because we detect nothing outside. Okay, that's why sometimes the contour seems to be doubly thick, right? It's fat, it's a fat contour. Now the question is, how do I fix this, right? To be honest, the easiest way would be to throw in something in the background. It can be whatever. In this case, I'm gonna throw in a huge sphere, nothing fancy, and make this really big. Okay, and remember, I don't want to see much, but I'm at 80%, oh, sorry, 80 degrees angle threshold, right? And the sphere, it's really weird because it shows me this much. It shows me every single one, right? So I have to increase the segments here. There you go. Of course, this, instead of the sphere, you can use a plane, but it doesn't matter. But it's not done. I need to detect separate meshes, right? I need to detect that this edge is no longer external. Well, it can be external to the object, right? I mean, if I do this, it will be external, but that's not what I want. What I want is kind of, you see what's happening here when I detect separate meshes? So when I do this, the same happens for the internal. Here's what's gonna happen. Redshift will detect some normals for this face and some for all these outside object, right? And because this is a contour generator and this is a contour generator, it does 2. Basically, 2 plus 2 makes 4. And at this point, you have something that's uniform. Okay? We don't draw contours on environment, unfortunately, right? So, okay, it kind of starts to make sense, right? So let's make this a bit more interesting. Throw this in. And you can see at this point, everything is continuous and everything is the same thickness, right? Which is good. But remember, you had to go through a bit of loops, right, to get this right. And in this case, the surface is extremely simple, to be honest. Let's complicate things a bit, right? Let's get rid of the correction because we don't need that and add a bevel. And let's make this bevel a bit larger. And one little thing you're gonna notice, I lost my internal edges. Okay, and the reason I lost my internal edges is this. The angle between this face, which is pointing there, and the angle of this face pointing there, it's not 90 degrees. It's actually probably 45 as a difference. So unfortunately, I don't think it's a good idea to render from the front. I need this guy. So what I'm gonna do is lower the angle threshold. Okay, and we're not there, we're below something, and one little thing weird happens here, right? I'm at 30 something and it looks like I broke my contour. Something is really fishy here, right? It doesn't quite make sense what's happening here. And sometimes I'm getting this edge, but it's kind of an outline, but sometimes I lost it here. What can I do? Well, the secret lies in the way these are computed. There's difference between normals, right? And you have to go to the cube and play with this little value. Okay, make sure that the normals that this cube are producing can be properly used. Okay, and you can see here we have the intersection, everything's fine. Okay, now I'm gonna introduce a new thing here into the mix, and that would be transparency. We do have a limitation of some sort, and I'm gonna get rid of this and introduce an incandescent. And the reason for this is quite simple. Incandescent has transparency or opacity. And something looks weird already, right? If I take this guy and put it on top, sorry, not the sphere, the cube, I raise it a bit above the ground, I lose my back-facing contours. So one of the limitations that we actually have with this is that we cannot trace back-facing or back faces through transparency. of the same object. Yeah, I know it sounds a bit weird because, hey, wait, I can see that you can do it with different objects. Yes, it's just not self back facing contour. That's not kind of working, right? So we have to be aware of this. I can rotate this and get a different feel. It starts to get interesting and weird at the same time, right? But one little thing you want to do is try to keep these from touching themselves. You're either going in or out. Let me zero out the rotation. And this is what? This is 200. If I make this 100, you see what's happening? Because these two are overlapping, it doesn't know what to do. So it creates this black edge. So either you go outside, above, or below. And you have to balance this nicely. It's not always easy. Okay, so if you're working with transparent objects and you need contours, be aware of this little thing. Okay, now you can see here that the contour has a multiplier. It's called thickness modifier, right? And this is something you want to play with. In this case, I'm going to use a maximum noise and connect it to the thickness modifier. And this kind of makes the whole thing a bit more interesting because it varies the result. And yes, I can contrast this to make it kind of like dotted line. And because this is in object mode, when you transform your object, the contour goes with it. Of course, you can see here again the intersection period that happens because everything is kind of transparent for it. Okay, and this is all nice and dandy. The problem is that if you're thinking about animating this, let's make the speed a bit bigger, and it doesn't have a direction. I mean, you might think about it, hey, I want these to go that way, these to go that way, and these to go that way. No, it won't happen because you can't animate the maximum noise that way. You have to find a different way, probably constructing all sort of projections if you want, right? But it's something that's just really fun to play. If you don't want the maximum noise and you want something that's more, let's say, not necessarily down to earth, but let's say if I take the cell noise, right? It's kind of okayish, but it doesn't give you a clear dotted line, right? So I'm gonna use the tiles. The reason for this is quite simple. The tiles can do something like this, right? So if I make this black and get rid of the growth and the bevel, I'm getting a checkerboard, which I can use to actually make this working. I probably have to make this a bit thicker. It's kind of okay, and then we can work on the size of this guy. So let's see, UV scale 0.5 and V scale 0.5. Actually, I have a global scale. Why would I bother with these two? Big lines, small lines. Right now, there's a little thing that happens here. You can see here, these are kind of okay, but here they're not. And at this point, you have to start playing with the thickness again and try to balance everything, right? And that's because you're getting grayscales here, and you don't quite want that. You see here, some bits are not perfectly overlapping, right? I mean, when it's just one, it's okay, but when you go down, because this is in UV space, you have to know exactly what you're doing. So let's make this 0.5. There you go, they work again. 0.75, not quite, they're half-half, right? So you have to balance this. If you, this is it's UV space, and whatever you're creating has to be in UV space one way or another. But you can see here, this is looking weird, totally weird. It's kind of like there's a bit on the left and a bit on the right. I don't know if this is clearly visible, but think about it like this. You have zero, because this is black on this side, and you have 1 on this side because this is white. Yes, it's gray, I know, because we're using ACCG, and in ACCG white is not white, it's kind of gray, and you need super whites to have white in sRGB space. But I'm digressing, right? So remember, for each kind of part that gets contouring, right, this is actually happening for the contour inside the contouring faces, let's say, right? This can be more than one face. So this side of the contour has a thickness of 1, or a multiplier of the thickness of 1, and this one has 0. And it looks like a weird dotted line if you want. Here everything is clear. 1 1 0 0 1 1 0 0, right? And in the end you're getting with a clear dotted line. In here, not so much. It looks like some bits is like that, some bits is like that, and it's in this case it's just a side effect of the UVs. Right, now if you don't like this, not a big deal. Let me just try to get back to wherever this is. I'm kind of losing the viewport. Where is this? Oh, okay, I flipped the view. And let me make sure that the camera is in object mode. Okay, so when I rotate, it's like this. So UV space might not cut it, right? So what can you do? Well, you can try planar it. Okay, and because this is in object space by default, right, this is all working, no problem whatsoever. Again, this transparency thing is just because I have no alpha. I can get rid of that in a sec. Right, you can see now you have dotted lines everywhere, kind of everywhere, because, well, maybe here you don't. Again, the same problem with this, so maybe you want to offset this slightly. Maybe it's not the right axis, because if you're looking at this guy here, there you go, you're trying to have the same colors on each side, and the fact that I'm somehow trying to offset this is maybe not the best thing in the world, right? Let's see, we have this bit which is working fine only on this edge because it has the same contour left and right. These, not so much, right? So you would need somehow to get some sort of projection or a way that gives you constant or the same values on each side. Now you can project this differently on each face and flip it and so on and so forth. I don't think we have to go into that in terms of complexity, right? I mean, I don't need the blend curves or the blend amount, and this won't work anyway. So it's a bit of a weird situation where I'm forcing some things to be what they are not, but it depends again on how this is built. Now, if this was built a bit different, let's say this was a ramp, which is again in 2D space, right? I can look at this, there you go, but the ramp has noise. Okay, and I can control the size and things like this, right? You can see you can get these interesting effects. Actually, you can see it in the background and makes some really nifty things to play with. And of course, you can get in here and make this a bit more interesting, right? So you can do a lot of things. You have to remember though one little thing. The contour doesn't get any shading, so it will be flat. That's why it looks thick when you have it internally on both sides. Okay, well, I hope this clarifies things a bit and just lifts the fog of confusion over this contouring and thickness and things like this. Hope it helps. Happy shooting. Cheers.